So this week we are going to cover cohort studies. So last week we talked about case control and cross-sectional studies. Cohort studies are the other design that is very commonly used in epidemiologic research. So your case control and cohort studies are really the major designs that we talk about when we're talking about epi research. Obviously there's other designs, but these are the big ones. So, remember when we talked about case control last week, you started with cases of disease, right? In a case control study, you started with the people that had the disease, and then you identified a relevant control group to go with those people that had the disease. In a cohort study, we do it the other way around. In a cohort study, we start with everyone being disease-free. So at the beginning of a cohort study, no one has the disease. You have people that have the exposure of interest. You have people that do not have your exposure of interest. And then you follow all those people across time to see who develops the disease. So because cohort studies start with a disease-free population, we're starting with everyone as well. Nobody had the disease of interest in a cohort study. Because of that, and because we follow them through time to see who develops the disease, we know we can establish the temporal relationship between the exposure and the outcome. We know definitely that the exposure occurred before the outcome in a cohort design, right? We could not say that about the case control. But in the cohort design, we can say we start with exposed and unexposed groups and no one's sick. So we know that that exposure occurred before the outcome of interest. This becomes really important when we start talking about causal relationships, so establishing whether or not your exposure actually causes your outcome. Let's see. All right, so there's two types of cohort studies. Yes, did you?
Yeah, so it's about exposure. Could exposure have happened like after the study begins too?
It depends on how you're defining your cohort. So in a typical cohort study, in a traditional cohort study, let's say that way, where you've identified an exposure that you're interested in, you would just gather all those people that had that exposure, and then you would find people that didn't have that exposure that were from the same source population. Alternatively, there are some cohort studies that are done, like, who's heard of the Framingham cohort? Yes? So Framingham, Massachusetts, this study's been going on for like 30 years, actually probably longer than that. I don't remember when it started. But yeah, so the Framingham study, they had this huge group of people that all entered the study. And they were interested in various, the original study was interested in cardiac outcomes, but they collected data on a bunch of stuff. And so at the start of the study, they collected data on a whole bunch of different exposures. So everyone in the study kind of like entered the pool, and then they identified who had what exposure at the beginning. But it wasn't defined that they weren't entered into the study because of a certain exposure.
Right.
So in that instance, yes. But for the most part, you're really talking about people you have identified that they have the exposure, so they will have the exposure at the start of the study.
Like, would it be possible to, like, after, like, so let's say it's in a case like that where there's been data collected on more than just, the cardiac data, right? So could you do, like, a separate, like, cohort study based on, like, the executed that they already have?
Yes, you can. Yes, we can. We'll talk about that in the next slide. Yes. Oh, no, it's a very good question. So, in prospective cohort studies, and we're talking about the simplest form of the study right now, okay, right? You would say, today is not 8/29/2010. You can tell when I did these slides, right? Let's say today was August 29th, 2010. We would start today, and we would identify people that are exposed and unexposed, and everybody at the start of the study would be disease-free. So, and then we would track them tomorrow and the next day and for the next weeks and months and years. And as people develop the disease, we say, okay, you developed the disease at this time. You developed the disease at this time, all the way through the end of our study period. So it takes place in real time. Today we identify people that are exposed, and then we'll follow them forward through time, and as people get sick, we will count them as a case. In a retrospective cohort study, we use data that already exists. So we have, let's say the Framingham example, we have all this data from Framingham. So we can go back and look at all the data that was collected 20 years ago and see who has the exposure of interest, right? And so we look back 20 years ago and we look at all that information and we identify the people that were exposed, let's just say smoking. We would identify the people that were smoking 20 years ago and the people that weren't smoking 20 years ago. And then we have all this data across time to look at, so we can still track those people forward through time to see who developed lung cancer, right? In real time, all of this has already taken place. However, we're still going back, we're using data that already exists and retrospectively looking to identify the people that were exposed 20 years ago that didn't have the disease 20 years ago. And following them up until today to see who got sick. Does that make sense? Kind of? Yeah? But in both cases, we're starting with exposed people. In both cases, when we start collecting the information, when we start identifying the exposure, none of those people have the disease that we're interested in. Alright, so this is just a different graphic if the other ones didn't do it for you, as far as understanding the temporal nature of the exposure and outcome. Wait a minute. Oh, there we go. This is just kind of drawn differently. So you have your people that you're interested in, you have your exposed population and your non-exposed population, and then you look to see who develops the disease and who doesn't within each of those groups. In a prospective, we identify these people today and follow them forward through time. And in a retrospective, we look back at secondary data and then follow them to today. Now, it's also possible to combine these two and to look back, identify exposures from 20 years ago, follow them to till today, and if you still have access to those people, then you can continue following them forward through time. So you can have a retrospective and prospective aspect. But most of the time, you do one or the other.
What's that called then?
If you do both,
Yes.
it's got prospective and it's retrospective and prospective.
Okay.
Yeah, there's not a special fun name, or if there is, I'm not aware of it. Maybe there is, but. All right. So, remember when we talked about case control studies, we talked about the importance of a case definition, right? You had to identify, you wanted to make sure your cases really were cases of disease. Well, we also have to have an adequate exposure definition. So, similarly, we have to define who's going to count as having the exposure and who's going to count as not having the exposure. So, for instance, if we are talking about smoking, and we want smoking to be the exposure, does exposed to smoking mean that you smoked a pack a day for a year? Does it mean that you ever smoked a cigarette? Right? There's lots of different definitions that we could use to classify someone as a smoker. So up front, you have to decide who is going to count as being exposed and who's going to count as being unexposed. And it's up to you to develop that definition. Now, obviously, in a lot of cases, there's existing research where people have used consistent definitions, and you would want to go by that. But it's the researcher's job to define who's going to count as exposed and who's going to count as not exposed. Now, what you want, if you really can get it, is to have your unexposed people come from the same source population as your exposed people. Because you want your unexposed people to give you the baseline rate of disease if you weren't exposed. All right, so we start at the beginning, and we're following to see who develops the disease. So the unexposed people are going to tell us how many people would have developed the disease regardless of the exposure status, right? Because those people weren't exposed. So what's the baseline rate of disease in the unexposed population? And then we compare that, and we want to see if the people that are exposed have a higher rate of disease, right? So we want them all to come from the same source group of people. Now, this is not always possible. So let's say if you're interested, the exposure you're interested in is asbestos exposure in textile workers. Well, you couldn't have an unexposed textile worker group because they all would have been exposed to asbestos by definition. But you could, however, find a group of cotton textile workers, right? And so you want to make sure that your unexposed group is as comparable to your exposed group as possible. Let's see. Sometimes you can compare to baseline rates that you find from just general aggregate data that's already collected. So that would be comparing to the general population. So if you have surveillance data that the government's already collecting, or if you have administrative data from a hospital, you can use that to find the baseline rate. So you would compare your group of exposed individuals just to the rate of disease within the general population. Do you have a question? No. Okay. All right. So how do we ascertain exposure status? If it's an acute event, like an exposure to a chemical in a plant, that's pretty easy to say who was exposed and who wasn't exposed, right? The people that were working at the plant and that were in that room when the chemical leaked, those people were exposed. But there's a lot of other circumstances when exposure is not as easily determined. So, depending on what we're looking for, sometimes we can assess exposure through medical records. So, did people have a certain type of surgical procedure, right? That might be our exposure of interest. Sometimes we can assess through interviewer questionnaire. Did this happen to you? Did you ever take this drug? Did you ever fall down? I don't know. And then sometimes we can directly measure it through like blood tests. Right? There are certain things that you're exposed to. If you have heavy metal toxicity, we can test your liver and find out that you've been exposed to heavy metals. Actually, you can test your blood for that. But, and then you can use proxy measures. Who remembers what proxy measures are?
You're directly measuring something for something else.
Exactly. So, can you give me an example?
If you're looking at like poisoning kids, you have to ask the parents if they were around like lead paint or whatnot.
Exactly. Yes. So you would be asking someone who could report. So if it's a child or someone who's mentally unable to answer, you could use it. Or it could be something like using education as, yeah, that's the one you were going for, right?
Yeah.
Using education as a measure of socioeconomic status, right?
That's the example you used last week.
It is the example I used last week. It is the example I always use. I'm very consistent in that regard. All right. So, measures of association. What was the measure of association for a case control study?
Odds ratio.
The odds ratio. What was important about the odds ratio? What was the important aspect of it when we were talking about it? There was something I was just like pounding into your head. Anyone? Anyone? You can. This little corner over here is really good. I want an answer from like this group. Odds ratio. When we were interpreting odds ratios, could we directly estimate risk from a case control study? Answered words.
No.
No. No.
Because it's not relative risk.
That's right, because it's not relative risk, because we can't establish the temporal relationship between the exposure and the outcome. So when we were talking about an odds ratio, we were calculating the odds of having exposure, given that we know you're already sick. In a cohort study, we're starting with people that aren't sick. And then we are seeing them as they develop their illness. In a cohort study, we can directly measure risk. We can directly measure risk because we're starting with the unexposed, and we follow them forward, and we identify who gets the disease. So, our measure of association for a cohort study is the relative risk or the risk ratio. Those are identical terms. You can use either one, I don't care. Relative risk or risk ratio, same thing. Now, the relative risk represents the risk of getting the disease in the exposed population compared to the risk of getting the disease in the unexposed population. So we could also say, if we wanted to use probability terms, we could say it's the probability of disease given that we know you're exposed compared to the probability of developing the disease given that we know you're not exposed. The exposure measures. How do we calculate it? So, in this example, who wants to tell me what our exposure is in this example? Who wants to guess? We set up our 2x2 tables the same way.
Medicare.
Exactly. So, when you're setting up your 2x2 tables, you're always going to have your disease state, your outcome state in the columns, and your exposure state in the rows. If you set your tables up this way, then the calculations will make sense based on the formulas that I have given you. There we go. Obviously, you could rearrange the numbers and figure it out, but if you want to just remember these, you can just set your table up where you have your outcome and your exposure. So, our disease in this particular study, we've done a cohort study where we were examining our exposure, whether or not you had Medicare or Medicaid versus all other insurance, and if that led to a long stay or a short stay, short length of stay in the hospital. So we started with a whole bunch of people at the beginning of their, well, in this case it would be at the beginning of their hospital stay, and we said, okay, do you have Medicare or Medicaid, or do you have other insurance? And then we followed them forward through time and determined whether or not they had a long stay or a short stay. And this is what we got. So, in order to determine the relative risk, we have the cumulative incidence among the exposed and the cumulative incidence among the unexposed. Does the phrase cumulative incidence mean anything to anyone? Okay, well, let's ignore cumulative. What does incidence mean?
The number of cases.
Number of what kind of cases?
New cases.
New. Incidence means new cases. New incidence of disease. Cumulative incidence simply means we know the entire cohort. The entire cohort stays the entire cohort for the full amount of time. It is a fixed cohort. Does anybody remember that term? Fixed cohort. Nobody moves in and out. Across time, we have information about everyone. So this is a fixed cohort. Cumulative incidence you can only calculate when you have a fixed cohort. But it's just the number of new cases divided by what? Who wants to guess? The total what? So if we have the cumulative incidence among the exposed, we have the number of people that developed our disease. In this case, our disease is long stay.
Only like the total people in your study, kind of?
Total people in the exposed group. Yeah. So the cumulative incidence for the exposed group is just the number of people who got sick, or who had a long length of stay in this case. These are the people that have our outcome of interest, divided by everyone that had our exposure. So our cumulative incidence in the unexposed is the number of people that got sick out of everybody that didn't have the exposure. And just like the odds ratio, we're taking a ratio of those two. So, yes?
Can you repeat that last part? You said for the unexposed, what was the equation?
It's the number of people that had the disease that had the outcome of interest divided by everyone that was unexposed.
Okay.
And we take the ratio of the cumulative incidence in the exposed to the cumulative incidence in the unexposed, and we get our relative risk, or our risk ratio. Call it either one. Who wants to take a stab on how we interpret a relative risk of 2.02? We're just guessing. We obviously haven't talked about it yet. It would have been in your reading. Mm-hmm.
You have 2 times the chance of having the disease if you've been exposed.
Yes, that's exactly right. People who are exposed are 2 times more likely to have a long length of stay than people that have the other insurance, right? So people that had Medicare or Medicaid, our exposure, are 2 times more likely to have a long length of stay compared to people that have other insurance. Exactly, because this time we actually can talk about exposure leading to disease, right? Because we know the exposure occurred before the disease. So, this is exactly what you just said. So, we'll be fine. All right, strength of the relationship. We interpret the strength of the relationship the same way we do the odds ratio. So between 1 and 2 is considered a weak association, 2 to 3 moderate, above 3 is strong. 0 to 1 is a protective effect. Remember, this is a ratio, so you will never have a risk ratio that's less than 0, right? If you do, your math is wrong and you should start over. It should never be negative, but if it's between 0 and 1 is a protective effect, anything above 1 is considered not a protective effect, a risk factor. If it is 1, what does it mean if you have a relative risk of 1? Someone in the back of the room. Someone not wearing a tie. I don't know. Yes?
There's no effect. Or like
Exactly. There's no association. Now why? If you have a relative risk, is there no association?
Because the number of those who got the disease who were exposed is the same as those who...
Exactly. It's a ratio because the number of people who were exposed that got sick is exactly the same as the number of people who were unexposed that got sick. So obviously the exposure is not causing the disease, right? Excellent. All right. Now, both the odds ratio and the risk ratio are measures of, or estimates of relative risk. They are relative terms. You're comparing one group to another group. What they don't tell you is that they don't give you an absolute measure of risk. So they tell you group A is more or less likely to get the disease than group B. They don't tell you that group A has this much excess risk because they were exposed to the disease. So attributable risk is simply the added risk of disease due to the exposure. So, because obviously in the unexposed group there's some baseline rate of disease, right? So it's possible to get this disease even if you didn't have the exposure. So there's a baseline rate. Attributable risk is telling you, okay, now that you have the exposure, this is how much more likely. Or more likely is not right, that's the probabilistic term. It's the added risk of disease. Population attributable risk, is how much disease in the population is due to the exposure. And what I should have done was come up with really great concrete examples, and I didn't, so I will pull some up in a little bit and give them to you, because I think it makes these terms a little bit easier to understand. So I will do that when we have a break, and we'll talk about it again. We're not going to talk about calculating these, it's kind of beyond the scope of this class, but just know that they exist. Alright, so why are cohort studies great? They're efficient for rare exposures. Why do you think they're efficient for rare exposures? What does that mean?
Because you start with the exposure, so you can pick a rare exposure and pick a cohort around.
Exactly, you can identify all the people that have that exposure at the beginning, and you can make sure you get enough of them at the start of your study. Exactly. You can evaluate multiple outcomes. So you can look to see, is this exposure that I'm interested in, is it related to cardiovascular outcomes? Is it related to neurological outcomes? You can look at all, you can assess all of that stuff because you're collecting information across time. So as long as you remember to track it, you can look for multiple outcomes. It is less vulnerable to bias than case control and cross-sectional studies. We're going to talk about bias in a couple of weeks. It is not immune to bias. It is less vulnerable. And then there is the clear temporal relationship between exposure and outcome. We know when we do a cohort study that the exposure preceded the outcome. And that is important because you can never establish something as being causally related if the exposure is not preceding the outcome. I cannot say that A causes B if A did not come before B, right? Cohort studies allow us to say that. They give us that power. Yay, power. Alright. Weaknesses. They're inefficient for rare outcomes. Who wants to guess why they're not good for rare outcomes? Okay, the same three people have answered everybody. Go, yes.
You're probably not going to look and study a rare outcome when you're going to try to go for heart rate, whatever. You're not going to look at your big toe or something rare that doesn't matter for what you're.
Your big toe doesn't matter.
Okay, but compared to you're not going to measure heart rate, blood type, that type of thing, and then something random along with that. If you're going with an exposure that's going to likely affect like blood type or heart rate.
So that's setting up like what your research question is. So you're right, you're absolutely not going to like study your big toe if you're interested in cardiovascular outcomes. But your big toe is not necessarily rare. So I'm talking about something that does not occur very frequently. So we have studies. So you have this outcome, you have this disease that does not occur very often. Very few people have it. We want to know why it wouldn't be efficient to use a cohort design.
Because you won't
Find
have as many, like, that outcome won't happen that often, so it's hard to study that.
Exactly, the outcome's not going to happen very often. And the amount of people that you would have to start with in order to ensure that you had enough people to analyze at the end, it would increase your sample size exponentially. You would have to have a huge number of people at the beginning, just to ensure that a few people actually develop the disease you're interested in. Right? Whereas with the case control study that we talked about last week, it's great for rare outcomes because you start with the people that have the disease, so you can just grab enough of them and make sure that you have all of them. Right? If you're talking about a retrospective cohort study, remember, in a retrospective cohort study, all of the information was already gathered and we're just using existing information to answer our question. Sometimes there's not the information that you really want, right? So you end up using a lot of proxy measures, or you end up having to slightly change your research question just because the data that you want doesn't exist. That doesn't happen in a prospective study because you know that you want it, and so you can collect it as you go. But in a retrospective design, cohort design, you're limited by what already exists. You're limited by the secondary data. Prospective cohort studies are expensive and time-consuming. They require large groups of people to ensure that you have enough of the outcome of interest, and you have to follow them for a very long time. Because if you're interested in something like the development of cancer, you don't just get infected with the germ and then develop cancer tomorrow, right? These are slow conditions. These are conditions that take years and years to develop, so you have to follow people long enough for the disease actually to manifest. So many cohort studies go on for 2, 5, 10 years. The Framingham study is still going on. I need to look at when that started. I think it was in the 70s. And they're still collecting data on it. And then prospective studies are inefficient for diseases with long induction and latent period. Who wants to guess what an induction period is? You guys all have a mind somewhere else today, don't you? Yeah.
Is it like how long it takes for like the disease to kind of show up?
Mm-hmm. Yeah. So you've had the exposure, and it's how long it takes for you to biologically have the disease. And then the latent period is the time between the time that you biologically have developed the disease and the time when it actually shows symptoms. Right? All right. So when do we want to do a cohort study? When we know the exposure that we're interested in. That's helpful since you have to start with the exposed group, right? When the exposure is rare and the incidence of disease among the exposed is high. And yeah. And then when the time between exposure and disease is short. That's very helpful for prospective design. Now, retrospective designs aren't necessarily limited by that, so long as you have enough time in the data. All right. Sweet. We will totally be out of here by 4:30. All right. Here's what we're going to do, because this little exercise is kind of on the longer side, but we will be done. I'm going to pass these out. In your slide deck that I posted today, all the students, there are a series of figures and tables, maps and stuff that you will need. I noticed today that I had added some other slides, so now when I indicate which slide they are, you have to add, this is slide 13, you have to add like 2, 3 slides. No. Slide 13, what slide is this? I don't know what slide that is. 17. So you have to add 4. So if it says the map on slide 13, it really means the map on slide 17, and so forth. Everybody can figure that one out. You guys are smart. All right. So, this part too. Okay, excellent. What I want you to do, obviously, break up into groups, because that's what we do here. There's questions embedded within the narrative. I want you guys to answer those questions in groups, and let's try to be back by 3:45. And if you finish before that, just come back and we will finish early. And if we get out of here even before 4:30, we do great. But I decided I'm really going to rush, you know, I was like, feed us on through. 3:45. Did I say 4:45? Because I would really like you back by 3:45. That would be helpful.